Step back and think about it for a second. We told you that the mean is the value that harmonizes our data. It makes our data rest or balance. And then we've also shown you mechanically how to compute an average by hand in Google Sheets or Desmos, but we haven't really offered you any explanation as to why the mean makes your data balance. And there are several different explanations that each have some appeal, but one of the most important ones for our purposes is this idea of how it balances out deviations. And so I'm going to walk you through this, and first we'll do it with no outliers, and then we'll also take a look at what happens if we add an outlier. We've already calculated that our mean is equal to 3.68 for all of our how many full glasses of water did I drink today? And what I'm going to do is I'm just going to say this value here is equal to the value up there. And this is important because if anything changes up here, it'll change down here. So let me just show you, oops, I didn't drink 3 glasses of water on day 1. I only drank 2 glasses of water on day 1. Well, that's going to change up here, and it's also going to change down here. All right, well, what I'm going to do is I'm just going to take this value and then do one more thing, equals the value up top, so like one above me, and I'm going to drag. I'm going to drag all the way to the bottom, and I really should just end up with 3.68, 3.68, because that is the mean for all of my data. Why would I do this? From here, I'm going to calculate a deviation, and a deviation is just the difference between the actual data point that was observed and the mean data point. So in this case, it's going to be equals 3 minus the mean, 3.68. And what this is telling me is on day 1, your consumption of full glasses of water was 0.68 units below the mean. So some of my deviations will be below the mean, and some of my deviations will be above the mean. And we are going to just drag all the way down the column, and it's going to repeat that formula. What actually happened minus what is the mean. And so on day 2, I consumed 4 glasses of water, which is 0.32 deviations above the mean of 3.68. Great. Now this is where things get interesting, and I want you to pay careful attention here. I'm going to make a mistake on purpose, okay? So follow me. A lot of times we've been just kind of working with column D. I want you to see how this could end up going wrong at some point. So we have 31 days of observation, so 31 data points. And again, I'm going to make a mistake on purpose. So I have this little mini table, and it says positive deviations, negative deviations, and total. And then I'm counting the number of positive and negative deviations, and then I'm taking the sum of these positive and negative deviations. And, I'm just going to even dress this up a little bit, bold. Here's the formula that I want you to pay attention to. I'm going to put in equals count if. So Google Sheets, I want you to count, but I only want you to count if, and I'm going to highlight the column. Hint, that's where the mistake comes in. And then I'm going to put quotation marks greater than 0. So I want the positive deviations, and so every time I have a deviation that is bigger than 0, count it. And it looks like, hey, there are 16 positive deviations, 16 times where your actual consumption is greater than the mean. Let's do the same for negative deviations. Now, I should say, maybe I should put non-positive deviations. You get the idea. But I'm going to put equals count if, and I'm going to highlight column D, and then I'm just going to say less than or equal to 0. And then end quotation marks, and I get 16. Now remember, this is maybe where you should be scratching your head. There are 31 observations, right? But the sum is 32. Well, let's look at what happened, and this is where you just have to be careful when you're working with spreadsheets. In column D, we have the mean, which is not an observation. The mean is not an observation. It's the mean of the observations. And I can't very well just kind of delete it, because as soon as I delete it, then it's going to delete that whole column. So here's what I do is now instead of just saying column D, I'm going to have to say, okay, well, it was all the values starting at D3 and going down to, looks like D33. So D3 colon D33. There you go. Now I'm back to 15. I could do the same thing here. In fact, I will do it just to stay consistent. I'm going to go up to the formula bar, D3 to D33. And no change here. Okay, great. Well, so now we know that that's the range, and that's a mistake that somebody could make. It's kind of a side note. But here's where things get really interesting, because this defends the claim that what the mean does is it balances our data perfectly. Instead of count if, I'm going to put in sum if. Add a bunch of things together, but only add things together if it meets a certain rule. So D3 to D33, and what I'm going to put in is quotations greater than 0, quotations. So what you're looking at right there is the sum of all the positive deviations. So 1.32 plus 2.32 plus 4.32 plus 2.32, you get the idea. Every positive deviation just got added. And now let's go to the negative deviations, or maybe the non-positive deviations. And I'm going to do the same thing. I'm going to say sum if D3 to D33, comma, quotation marks, less than or equal to 0, quotation marks. And look what happens. My negative deviations or non-positive deviations are identical to my positive deviations. The sum total is 0. And that is because my arithmetic mean perfectly balances out all of my data. And if any of my data points change, well, then the arithmetic mean is going to change, and it's going to maintain that balance. So if on day 3, I didn't have 1 glass of water, but I had 0 glasses of water, well, that would drop the arithmetic mean down to 3.65. That would change every single one of these deviations, and the sum would still come out to 0, because that is what the mean does. I am going to just show you that any other number besides the mean will not achieve this. Let's try something like the median. The median was 3. Let's go up here, and I'm going to just hard enter the number 3. Well, that is the median, but in this case, our median is not our mean. In fact, more often than not, your median will not be the same as your mean. In this case, it looks like we have positive deviations of 21. Or let's go with the modal value of 2. Well, now our positive deviations won out again at 52. What if we had gone with a value like 4.5? Well, in that case, the negative deviations win. We're at negative 25.5, 19 positive deviations, sum total of 44.5 negative deviations. So you get the idea. It is only the mean average of my data that will perfectly balance out the positive deviations with the non-positive deviations.